To end with our preliminaries, let us consider finally the production possibility set and the possible allocation. What is the production possibility set? Well, it is simply the set of all the possible vectors of good which can be made available by means of production. The set will be denoted by large T, and a vector small t will belong to large T if there exist production processes for the different firms, Y1, Y2, etc., YF, such that T is the sum of initial endowment plus the sum of these processes. The processes are not necessarily optimal for the corresponding firms. There's a general definition. Well, let us see. Initially, there is this total endowment of goods, the sum of initial endowments of the different households. To these quantities of goods, we sum the quantities of goods which are produced by the F firm, minus the quantities of goods which are employed by the F firms as production factors. But since the component relative to production factors of these YF are negative numbers, we are really subtracting them to the initial endowment of goods. For example, if you have initially 100 units of a certain good and the good itself is in the main a product, and you obtain 40 units of product, in the end you have 140 units which are available to consumption. While if, for example, under good we have 80 units and you employ the whole 20 units as production factors, you have in the hand only 60 units of that good to be consumed. Is it clear? Given the different size of a component of YF, you observe that this sum of vectors always represents the total available quantities of goods after production. Can represent this set graphically, but it is the usual production possibility set we studied in the introduction. Suppose that there are only two goods, x1, x2, this is the set T. Is it clear? Any point T, small t, of this set represents a possible aggregate consumption by our H households after when the initial quantities of goods are integrated, so to speak, by those produced by firms or reduced by the quantities that the firms employ as production factors. Is it clear? Production possibility set. In the production possibility set, it is possible to isolate the set TA of efficient vectors. A vector T will belong to TA, if and only if does not exist a vector T prime, such vector T prime has all the components greater or equal than T, and T prime is different from T. In other terms, at least one component of T prime is greater than the corresponding component of T. Is it clear? This is a subset TE of all the vector T which are the result of efficient allocation of factors in the edge box. Substantially, this is the meaning of this definition. And T is the frontier, the boundary of this set, which is termed as the transformation function. T is this boundary, the so-called transformation function. What is well known from our previous introduction. It's nothing but a rigorous definition of a concept we illustrated in the general introduction. Is it clear? Finally, an allocation of consumption goods. An allocation is a large vector like this, X. Note that the components of this large vector are vector themselves. So this vector has an enormous number of components, n times h components. It tells us for each consumer what are the quantities of the end goods which are available to him in order to be consumed, obviously. An allocation. But a vector like this will be termed an allocation if and only if it verifies the following property. The sum of these components, these vectors, must be an element of T. The meaning of this condition is straightforward. This condition means that initially we produce some quantities so that in the end we have this vector T available. Then you distribute the goods contained in T among the H households, according to these vectors XH. You obtain the total consumption by our H consumers. But this total consumption must be possible. Must be obtained by means of available initial endowments and the production processes of the furnace. Is it clear? Generally speaking, we shall consider productive economies, economies in which goods are producible, according to the technological knowledge of the firms. However, there are some particular cases which must be underlined. What is an economy without production. Simply, is an economy in which no firm is able to produce any good. No firm is able to produce any good. However, it is possible that the firm can destroy some good. For example, consider the following case. Suppose that the production set of this firm is given by this set. This is YF. Note that every production process has both non-positive components. So, strictly speaking, this firm is not able to produce any good. It can only destroy goods. But also, the destruction of goods is an economic activity. Suppose that one of these goods is not really good, is an evil. For example, rubbish for an household. Rubbish is sold to a firm which destroy it, suppose that rubbish is the first good, by means of, suppose, some quantity of fuel. It burns rubbish and it destroys in a given proportion rubbish and fuel. This could be the technology of a firm which destroys rubbish. In this case, we have that for every, as the graphic shows, YF is a subset of the n-dimensional negative orthant, this set. Because every YF is included in this negative orthant. Is it clear? This is an economy without production. A particular case of an economy without production is the so-called free disposal economy. What is the meaning? There is at least one firm which can destroy goods singularly. Its production set coincides, in this case, with the negative orthant of the n-dimensional Euclidean space. If there exists an F such that this equality holds. This is a particular case of a previous case, of course. In the previous case, YF was a subset of this. In this case, there is no production for the firms, and in particular for one firm, YF exactly equal to the non-negative orthant, to the non-positive orthant. What is the economic meaning of free disposal? Do you remember free disposal by Salvadori? However, the point, the essential point is this. You can destroy singularly every good. Note this production process. It destroys this quantity of good one without destroying any other good in the same moment. Because of this particular case. There's the possibility of destroying singularly every good which characterize free disposal. In this case, an allocation can be written more simply in this way. Allocation is such that the sum of xh is not greater than the sum of omega h. What is the meaning? Some units of available good can be destroyed by the firms, and the remaining part is consumed by the households. This is a typical inequality which characterizes a free disposal economy. Finally, we have the pure exchange economy. Well-known extreme case in which no production possibility at all is possible, but inactivity. Pure exchange economy. For every f, the equality yf with this set which contains only the origin holds. What is the meaning? Only inactivity is possible. No firm has the technical knowledge to transform goods between them. So only inactivity is possible. In other terms, the only point in each yf is this point. Another particular case of an economy without production. In a pure exchange economy, since no good can be destroyed, as in these two cases, you have that an allocation can be defined in this way. Simple redistribution without waste of initial endowments among the age consumers. So, the second case is a particular case of the first, the third case is a particular case of the second. Also, the third case is a particular case of the first, not of the second. It's clear? All these three cases are without production, but there are many ways in which an economy without production can be organized. Now, after all these preliminaries, in the following video, we shall finally define general economic equilibrium in this abstract context.